All right, well, hello everyone to the fourth installment of the Career Prep Seminar Series that is in conjunction with the CES Club as well as the GEOS Advisory Board. And a couple announcements before we begin the lovely talk by Dr. Pearthree. The Career Prep Seminars, while this is the last one that's going to be going on for this semester, there will be more come spring, though the speakers as well as the times are to be announced. So please be on the lookout in your emails from your department, basically. And we hope to see you in the spring as well. So to give a little introduction on Dr. Pearthree, he's going to be talking to us about the Geological Survey, and he is the Arizona Geological Survey Director. So he has a lot of sway, and he's giving me a look like, oh gosh. But please give a warm welcome to him, and we'll get started here.
Thanks, Kayla. I appreciate that. I'm glad to have this opportunity to talk about our state geological survey, Arizona Geological Survey, and also more generally about state geological surveys and sort of jobs that one can have there, and the kind of research and investigations that we do. So I guess with that, I'll just jump in and share my screen. And as I told the folks before we started here, this is the first I've been able to avoid doing a Zoom presentation up till now. So this is new for me, so bear with me if it doesn't go well. All right, does that work?
Yep, that worked.
Okay, great, thanks. So again, I'm going to talk about the career possibilities at state geological surveys in general, and as I said, the kind of things that state surveys do and the sort of niche that they fill in the geoscience community. So that's what I've got in mind. It's not too ambitious of a talk, so I should have plenty of time for questions at the end. Okay, I just need to make my thing work here. Let's see. Okay, first of all, so what I'm going to talk about is my history and background, how I got to be where I ended up. Then an overview about what state geological surveys do, how large they are, and where they're located. It doesn't mean, obviously they're in each state, but some are in state government, some are in universities, that sort of thing. And then I want to talk about the types of research and investigations, that range of things that are done at surveys, some sample of that. And then a little bit about the kind of education and expertise required and what sort of employment opportunities there are. And then I'll finish up with several examples of the kind of research that we do at the Arizona Geological Survey that are representative of what state surveys can do, and just a small sample of what is done actually. So first, my education and background are all about me. I grew up in the Midwest in various places, and when I was looking for college, I went to Oberlin College, which is a really good college in Northern Ohio, which is where I went to high school. But when I went there, I had no idea that I was going to be I had no idea that I would end up being a geology major. But sorry, you're looking at my chest. Thanks to my wife for pointing that out. So anyway, I went there just kind of, I didn't know what I was going to major in, and I took an intro geology class and thought it was cool, and ended up majoring in geology, which set me on a course. So I don't know how many of you undergrads came in with the idea that you knew you were going to do geology, but a lot of people don't know that, and they just get interested in geology, and that's why it worked for me. So then I came out west for graduate school. I was fortunate to be admitted into geosciences at the University of Arizona, and because I got my master's and my PhD here. But the geosciences department is a fantastic department, and I obviously know lots of folks who graduated, have masters and PhDs from here, and I don't know any of them that didn't find this to be a tremendous learning experience. It's just the range of things, range of expertise in the faculty and the interesting courses. It's just wonderful. And then your student colleagues are just, they're serious and interesting people, and it's a wonderful learning environment. And the other thing about being such a large department, of course, is the diverse coursework and seminars that one can take. And I think that as undergrads, I'm not sure if you get that sense as much, but when if you do go to grad school, I mean, it's tempting to specialize these days, but I really do feel like getting a diverse background. Certainly if you want to go to work for a state geological survey, for example, having diverse coursework and experience is a tremendous advantage, because you don't really know what you're going to do when you get there exactly. Another really great thing about graduate school or undergrad here is the fantastic field experiences that you can get. I think the field component of geology has always been important, even though there's a lot of laboratory stuff these days. Getting out in the field is just a fantastic experience. And if you really want to understand geologic relationships, you obviously need to get out in the field. So it's great that this department still has, really emphasizes that still, even maybe a little bit less than in the time of COVID, but it's really important to get out in the field. And it's a wonderful environment. The geology here in Arizona's Southwest is so well exposed and so interesting. I mean, it's take advantage of that. And then the other thing that I did when I was in grad school was I worked part-time. I obviously had grad student support, TAs and RAs. But in addition to that, I did work part-time at the Arizona Geological Survey when I had time or when I had breaks in my grad support. So, and that was a wonderful thing to do. Obviously, got my foot in the door at the Arizona Geological Survey that way, but was able to do help out on some really interesting projects as a grad student. Okay, let me see. So my professional career, so as I was finishing up my graduate program, a position miraculously came open at the Arizona Geological Survey for a research geologist. Now, there aren't that many positions. There were only at that point there were 3 positions at that level, and one happened to come open because a fellow retired. And it turned out at that point that AZGS was looking to get someone who would focus on geologic hazards and surface processes, surficial geology, that sort of thing, which is what I do. So it was a really nice opportunity for me, and it was a nationally advertised position. It was competitive, but I was able to get that position. And when I started working at the survey, I basically established a research group with changing personnel over the years, but research group and focused on geomorphology, surficial geology, geologic hazards. But the way we were a pretty limited budget, state budget's pretty limited, still is. So in order to have people to work with me, we really needed to find external funding. So immediately when I started working, I started looking for opportunities to get funding from outside entities to help support. I mean, my salary was basically covered, but to get people who could work with me, we had to have outside funding. And so the good thing about working in these areas is there's actually quite a bit of demand for our kind of work. So it was possible to get outside funding, and it still is. What I've experienced since in the 32 years, I guess, since I started working there, is really tremendous colleagues, both internally in the survey and externally in the U of A and other colleagues around. It's just been wonderful people to work with. That's one of the best parts of the job. Another thing that I've been able to do, even though mostly limited to Arizona, Arizona's a pretty interesting place, and been able to do a lot of different things, research things, mostly somewhat driven by what we can get outside funding to do. There's some things we could just do with our state funding, but if we wanted to do more significant research, we had to find outside entities that were interested in funding those. And so that helped drive a fair amount of the research, but a lot of that stuff, just because it's applied and has immediate value to society doesn't mean it can't be interesting. All through this time, I've had really great opportunities to work with geosciences students, faculty, and both sometimes undergrads, and more often grad students. but also been able to put to work at the survey U of A graduates now and again. So the fact that we have this tremendous research this resource that that you're a part of is just wonderful for us. So let me go back one more time. So one thing I didn't talk about, it's just a sidebar, but when I was hired at the AZGS in 1988, we were part of the university for 2 months, and then we became a separate state agency. Eventually, we moved to an office downtown. So we weren't part of the university, but I did remain as an adjunct research scientist, and several others of us did as well. So we always had contacts with U of A and with Geosciences. And then in 2016, the governor's office decided that we would be better off being back in the university. So in 2016, in the middle of the year, we moved back into the university, which is where we are now. And it was a really difficult process to move back in, to move into different space and downsize significantly. But ultimately, I think the governor's office was right. I think we're well positioned in the university. It makes us easier to work with students and collaborate with researchers in the university. So right after we moved in here back to the university, I became director, and tragically our previous director died in an accident. So I was kind of left to fill in the job, but and I've been the director for 4+ years now. So the neat thing about this survey, it's not too big and there isn't too much bureaucratic load. So I've actually still been able to continue to do geologic mapping and research. So I'm still here. So that's enough about me. So a little bit more about state geological surveys, just kind of overviews about what they are, what they do, and then a little bit about the sort of employment opportunities that state surveys present. And again, I'm going to be generalizing. I know a lot about the Arizona Geological Survey and something about other surveys, but a lot of what I know is based on what we do here. Oh, yeah, I want to give a, sorry, I'm going. So why do states even have state geological surveys or any geological surveys? That's an interesting issue, and most states, actually Arizona's only been a state since 1912, but we actually had a territorial state geologist and something proto-geological survey going back to the 1880s. So states and other states that existed started having state surveys in the 1880s, in the 1800s. So states kind of realized that there was value in understanding the geology of their states. There's a lot of it with mineral resource, or just trying to understand the geology, but what sort of geologic resources are there available? Since then, obviously, the need for geologic information is more diverse. But the same thing with the US Geological Survey, which was established in 1879, I think. It was the idea that the US needed to know about its geology in order to understand its geologic resources. So the core kind of thread, I think, for any kind of geological surveys is that we do applied research and investigations for relatively immediate benefit for society. A lot of the geoscience research that goes on in academia is certainly a benefit to society eventually, but a lot of what we do is really more where the rubber meets the road. Not all of it, but a lot of it is. So we'll do, if there's a specific concern about a geologic hazard or hazards for a roadway or something like that, that's the kind of research and investigations that we can do. We're pretty agile and we can start doing it on short notice. And the other thing about our work is that, of course, we make it available to the public almost immediately. So again, states have traditionally recognized the value of geologic information. Initially, it was almost entirely focused on mineral resources, maybe water resources. That's still true, but now we do more diverse things. Again, desire to understand and figure out how to exploit natural resources. And that was and is still a key issue for supporting economic development in the states. And whenever we want to make our case to the legislature that we're it's worth the amount of money, the less than $1 million that they send our way. We have to focus on the fact that if we don't understand our resources in Arizona, we really can't. It's an economic development issue. The other big thing that's been in the past 50 years or so is really a growing awareness of the impacts of natural hazards on people and infrastructure. And layered on top of that now, of course, is climate change and changes in the environment, more people. There's the nexus between geologic hazards and people and infrastructure is growing more and more acute. So there's a growing need for awareness and information about natural hazards in the states. So what do state surveys do? There's a whole litany of things, and this may not be a comprehensive list, but one key thing that almost all states do, 40 of the states at least, big thing that they do is geologic mapping and understanding the geologic framework through geologic mapping. And I'll talk more about that. But the nice thing about this is there's federal funding to complement state funding. And that's one reason why there's actually a reasonable amount of funding available to do this basic geologic mapping. And, well, let me say again, the nice thing about states is if you are interested in geologic mapping, state surveys are the place to be. It's the vast majority of geologic mapping in the United States is being conducted by state surveys. Then understanding and assessing metallic, non-metallic mineral resources. Obviously in Arizona, it's a huge deal with copper and subsidiary metallic minerals, but non-metallic minerals, aggregate resources, they're a huge part of any kind of construction and development. So access to aggregate, for example, is really important for any kind of developing area. And the other thing that's really a huge thing now with the, let's say, interesting relationship with China and overseas is the understanding that we rely on a lot of critical minerals and elements of which almost none of them are mined in the US. So we're very vulnerable to disruptions of the flow of trade, or maybe getting minerals from countries that we are having issues with. So there's a big push now to get a better understanding of the critical minerals in the US. Energy resource is not a big deal in Arizona, but it's obviously a huge deal in some states where there's hydrocarbon resources, or that's a big thing. Obviously, geothermal energy, things like that. That's a lot of state surveys do a lot of work in those areas. As I mentioned before, geologic hazards is an increasingly large focus for a lot of state surveys and has been for us for quite a long time, but a number of other states are going more in this way. Kind of a related, environmental engineering geology, so providing geologic data and information for understanding things like groundwater contamination or siting of roads, understanding problems related with engineering associated with roadways and other infrastructure. And then kind of again, a segue into subsurface geology. We in Arizona depend on a lot of our water comes from groundwater. And the groundwater resources depend on what, quantifying those depends on understanding the subsurface geology. In a lot of cases, we don't actually understand the subsurface geology that well. So that's a major uncertainty if you're trying to quantify how much groundwater is available, for example. Or if you try to understand maybe where you can safely have a septic tank and recharge your water and not contaminate the groundwater supplies. Another thing in subsurface geology that's really the current federal administration has been pushing, but it's been a long-term effort, is trying to figure out if maybe we can capture and sequester carbon dioxide from power plants. So decrease emissions by capturing it and sequestering it deep in the ground. And so we have a neat project that I won't talk about today that try to assess some areas in Arizona, their potential for carbon sequestration. And that's a national effort. And then another thing, especially, it's always been true, but being in the university, of course, outreach and educating the public about the importance of geologic information. And I think that's something that, you all are geoscience majors probably. So you understand how important geology is, but it's unfortunate how little that's conveyed in the primary and secondary schools, because geology is really important to society and most people don't have any appreciation of that. So we try to get the message out, how our work is important and our products are valuable. And then the good thing about state surveys, our survey and other state surveys, is that we're relatively agile. We don't really have a lot of, we can move quickly. We don't have huge sort of ossified infrastructures. So if we get an opportunity to propose to do some work and someone's interested, we can write up a proposal and get that in the mill really quickly. And that's a very, it's a major advantage that we have and most state surveys do. Not all, but most do. So if there's an issue that requires work and there's funding to do it, we will respond. So state survey sizes, they really vary dramatically in terms of size, location, but all but one state, Hawaii actually, which has some pretty interesting geology, does not have a state survey, but all the other states do. In a number of states, that survey is one person, but they range up in size up to almost 200. Annual budgets vary from about 350,000 in Vermont to 30 million appropriately in California, which is obviously a wonderland for geologic hazards and geologic resources and a huge population. So it's appropriate that California has the biggest survey. The number of full-time equivalents ranges from one, as I mentioned, several surveys are one state geologist, to 196 in Texas. California is close to that. And then the average FTEs are 38. The median is 28. So they're not big. Mostly they're not big, but they're sort of decent size. So 21 of these surveys out of 49 are in or associated with state universities like we are now. And I think there's not a tremendous amount of difference in terms of what the surveys do based on whether they're in universities or they're some kind of state agency. We have obviously have been both, and then there's not a huge difference in what we did when we were state agency or when we were in university. But generally, I think the surveys that are in universities are a bit more research oriented. And some surveys that are state agencies have some regulatory responsibilities like oil and gas regulation and that sort of thing. So we don't have that. Most surveys don't. So nearly all these state surveys receive some funding from the state. This is a graph that the Association of American State Geologists put together that show the state appropriations, cumulative state appropriations for state surveys going back to 1945. So you can see that percent of state survey funding was almost entirely state funding back in the 1960s, and it's been gradually decreasing since that time. So the states have been, to some degree, and it's not really that they've been investing less money, although that's sort of true, but really what this indicates is that states have been able to supplement the state funding. State surveys have supplemented state funding with getting more outside funding, and that's certainly been true for the Arizona Geological Survey. So you see, the total revenue has actually gone up as state funding has decreased. So basically states are making it up. More than half their funding comes from something other than their state appropriation at this point. So I'd say this is a success story, actually, of being flexible and responsive to the current funding environment. So again, the funding sources for the research that state surveys do, state appropriations is a base funding, basically. Some states surveys get money from mineral and oil and gas royalties and leases. We don't in Arizona, but some state surveys do. Another big thing, of course, is federal funding, and there are a number of different sources of federal funding. There's the National Cooperative Geologic Mapping Program, which I was mentioning earlier. That's basically providing states submit proposals, and they're evaluated competitively. But if they're funded, then the states provide 50% of the funding and the federal government provides 50% of the funding. So this is a base program that provides money for geologic mapping across the country. and digital products derived from geologic mapping. There's another relatively new program, which is exciting. It's Earth Mineral Resources Initiative, which is actually has a variety of things, but it's focused primarily on understanding better the critical and strategic minerals in the US. So we actually have a project this year and next year focused on trying to understand lithium deposits in West Central Arizona. So this is a new program, and again, it's federal funding with some state component. It's exciting, and I think this one will be growing because there aren't very many bipartisan issues in the Congress, but understanding our critical and strategic minerals is pretty bipartisan actually. So I think the funding possibilities for this are good. FEMA is a major source of funds for hazard and understanding geologic hazards and hazard mitigation. And then every now and then the US Forest Service, the Bureau of Land Management, National Park Service, or even the Department of Defense will pony up money to state surveys depending on what their needs are in particular states. And then the other kind of major component, I think, for a lot of states and is for us, is whether other state agencies, if we can do something, provide some geologic information that the Arizona Department of Water Resources, for example, needs, then we can submit work out a contract with them to do the work and provide them the results in a timely manner. It's a win-win situation for both of us. And a lot of state surveys do this. A lot of the state surveys that aren't in universities, a lot of times they're in some kind of Department of Natural Resources, so they have obvious partners with other natural resource agencies. And so that's true in a lot of state surveys. So then employment opportunities are relatively, this graph shows the state surveys on those bottom lines, and then the US Geological Survey is the upper lines, and the solid lines are the number of people employed, the dashed lines funding. So basically there's about 4 times as many people working for the USGS as the state surveys, but USGS has a lot of different things besides geology, biology, generating topographic maps. I mean, they do a lot of different things. So the number of actual geologists at the USGS may not be that many more than at state surveys cumulatively. You can see the trends of funding and FTEs are for state surveys have been pretty flat for the past 10 years, or even 20 years. So the employment factor prospect at state surveys depend on a lot of things that we can't control, like what's the economy doing, so therefore what kind of taxes are coming in and what kind of government, what's the prospect for government funding both at the state and federal level. And then society has to appreciate and prioritize appreciate the value of and prioritize getting geologic information. So that's a case that we need to make to our state legislature, which we've been pretty good about doing. Other surveys need to do that as well to make sure that they continue to get base funding. And then the idea that there aren't a lot of employment opportunities, so kind of have to be like, for me, for example, someone retired, so there was a position, those sort of things happen. These days, I think there's more employment churning, people change jobs more often, so, there are opportunities that arise. And there are roles for, as I mentioned, or as I said, and I guess I didn't say this here, so there are roles for PhD, master's level, and some bachelor's level geoscientists. There are also, because geology and geologic information is more and more GIS based, so there actually is quite a role for GIS and data information specialists in surveys now. There are some positive trends. The one is, as I mentioned, the diverse funding sources that state surveys are exploiting these days. And there is generally appreciation in Congress and in our state legislature for the value of geologic mapping to basically understand the basic geology. The importance of critical minerals to the nation, as I've mentioned several times now, and the increasing risks associated with geologic hazards. Again, the risks of hazards occurring are always there. With climate change, they're probably getting worse, and then more people and more infrastructure, that increases the risk. So now I'd like to switch to what we do here as examples. Geologic mapping supports and complements all the different areas of geology. It's understanding our natural resources, metallic minerals, rock products, and water resources. big deal in Arizona. Geologic hazards. We try to understand earthquake hazards, landslides, floods, and earth fissures. In Arizona, that's an anthropogenic hazard. We're providing our data more and more in a digital framework. Basically, all the new stuff that we do is coming out, taking advantage of big data sets, making our products available in a variety of useful GIS digital formats. Education and outreach, why understanding geology and the physical environment is important to society. We have to make this case all the time. And one thing about working for state surveys is everything isn't totally applied, and sometimes there's opportunities to do more fun, big picture projects. So now I'd like to give a few examples. So geologic mapping, this is a core mission. As I mentioned before, there's funding available, and there has been, but it's been an emphasis for Arizona Geological Survey since the mid-'80s. And this map shows all those different colors and squares. That's detailed geologic mapping. Geologic mapping that we've covered at 1 to 24,000 scale over these past 3.5 decades. So it's actually, it's a laborious process, but we've made good coverage, but obviously we haven't even covered a third of the state. So it's a slow process. State map program is the state and federal match is a very efficient. We map efficiently and the funding is put to good use. Now there's additional money that's been pumped into this program, so there's more available money for mapping than there ever has been before. And this has led to recent hiring, including, we just hired 2 new research scientists at the Arizona Geological Survey, and other state surveys have been hiring lately, partly in response to this increasing availability of money for mapping. This is a representative map of what we produce, 1 to 24,000 scale. This is a 7.5 minute quadrangle. It does require extensive field work, and that's a wonderful thing. It's great to get out in the field, see the geologic relationships. But we do both high quality bedrock and surficial mapping. So a map is a complete map, not just bedrock, not just the surficial deposits, but both. We compile our mapping in ArcGIS, so all the mapping is done. This map that you see here was produced in a GIS environment. And then we produce it as this is a static PDF. We don't do paper products. We don't print maps anymore. You can print them out yourself if you want them. But we produce them in geodatabase format and also in formats you can bring into Google Earth, for example, which is in some ways almost the handiest format these days. Geologic hazards has been a focus now for us for the past 30 plus years. But this is really a wonderful thing that we developed with some FEMA funding, and Uberg and others at the survey, Joe Cook and others have contributed to this natural hazards view. You can go on our website, see the statewide distribution of a variety of different geologic hazards. This particular example is of the first statewide compilation of mapped landslides, which is a tremendous leap forward. This is a based on, oh, sorry, let me go back. So based on mostly what was mapped and some new work, this shows an incomplete distribution of mapped landslides in the state, first of its kind. We keep a compilation of the historical earthquakes that have occurred. Those are those not too easy to see bubbles across the state, and also young faults. This is a way to understand the seismic hazard across the state, how it varies across the state. And this map is earth fissures that have developed in Arizona due to excessive groundwater withdrawal and land subsidence. These cracks that develop around the margins of the basin. We've had a program since the mid-2000s to map these features, and we keep that up to date. This is an important hazard to know about and to avoid. I want to show with a couple of projects. This is a really neat project that we just finished up. Again, Joe Cook led this one, and I know he's on the meeting, so I have to give him credit. But Joe Cook and Brian Goatee did most of this work. But basically, we got an opportunity. There was some end of the year state emergency funding that we did a proposal, got the funding, and mapped in more detail the landslides in a corridor around I-17. This if you've driven from Phoenix to Flagstaff, it's an increasingly busy corridor, and there are plans to at least make part of this thing widen it. So it's an area of critically to understand where the landslides are to try to minimize the problems associated with landslides as for the road and the expansion that's planned. So we mapped the landslides in this kind of bubble corridor around I-17. If you have ever stopped to use the facilities on the Sunset Point rest area, the next time you do, you can go to the overlook and appreciate that you're standing just above the head of a large landslide complex. So next time you look across the valley there, you'll know what you're looking at. But this is a large complex. We don't know how recently. It's probably complex and it's probably moved multiple times. We're not predicting that the rest area is going to go off in a landslide, but this is a large landslide mass that wasn't documented well at all until quite recently. And then this landslide that's just up north of the interchange of the road that goes up to Sedona, which there were a number of landslides mapped here, but Joe and Brian Goatee did a much better job of documenting this really large landslide complex named the Runaway Landslide because the runaway truck ramp is in it. This also showcases our ability to use drone technology to make digital DEM, digital elevation models, and relatively high precision things. And so this is really a wonderful demonstration of what we can do, useful projects we can do. And one last thing, this is more of the fun landscape development, but we collectively with researchers at the U of A Geosciences and USGS developed a new explanation for the development of the lower Colorado River, which was kind of beginning in the 1990s and we're still following through. Basically the idea that the river spilled through Grand Canyon, filled several basins on its way down and eventually filled basins of water and sediment, eventually spilled into the northern Gulf of California. And that's how the Colorado River developed through Grand Canyon and on down. This is sort of a series of models showing how we think it developed schematically, filled these basins with water and sediment, eventually made its way to the Gulf of California, cutting through these various basins and divides. So this is a collective effort driven by John Spencer and John Patchett at the U of A and involved a multidisciplinary projects, geochemistry, geochronology, geomorphology, sedimentology, paleontology. And really important as part of this process was geologic mapping to understand how this stuff fit together. So it's really cutting edge research that we were fortunate to be involved in as a state survey. So just to summarize what I'm yammering on about, state surveys really are great places to work. A lot of people start their careers like I did and stay there for the rest of their career. They really are good places to work. There are relatively diverse employment opportunities depending on what you're interested in and the size of the survey. We do a lot of field-oriented research and investigations, which is becoming less common in the earth sciences. Surveys still do that. We think that work that we do is useful and important to society, so that's a great benefit and justification for what we do. So the nice thing, if you stay at a survey as long as I have, is the kind of things that you work on can change through the years, and it's not a matter of doing the same rote things for years, year after year. You do a lot of different things. And the pay is not that great, but it's steady work. And you get to do kind of what, as long as there's funding, you can do a lot of different things. So I think with that, I would like to open it up for questions. That's our contact information and our my email, and then the website. Actually, it would be great if you jumped on our website to get a better feel for what we do. And obviously you can check out other state surveys websites as well. So with that, I'd like to open it up for questions. Maybe stop. I don't know if I need to stop sharing my screen. Maybe I do.
No, you can leave it up and then we'll have the contact information there during questions.
Okay.
Yeah. But yeah, anyone feel free to unmute or you can use the chat to post a question.
I have a question. Thanks so much for all your information today, Dr. Pearthree. I'm a master's student in the geoscience department, and I'm wondering if you guys ever offer summer internships with some of the graduate students in our department.
That's a great question. Thank you. We do. It depends on the projects that we have, frankly. So we have, we obviously have to have funding available, and then something that matches up with the students' interests. But we did actually so we have this carbon sequestration project that we're really just getting started in, and we were able to hire Lydia Bailey last summer for the summer to work on that project, and she was interested in that area anyway. So we matched up that way. So we're definitely open to that. I think for grad students, and I don't know what your situation is, but Geosciences is pretty good about funding grad students with, through their master's or PhD, whatever they guarantee you basically funding. So we have to work in around that, but we have hired, and we're delighted to if we can, because obviously we get great workers and people are really interested in doing this, and it's good experience, as I mentioned, when I was able to do that when I was a grad student. So that's a long-winded answer to when the short answer would have been yes.
Okay. And well, thanks. And I know Brian Goatee, he also did one of these career prep things with our department. And I asked him about, what's the best way to get your foot in the door at a state survey or maybe even the USGS. And he had said that just getting involved either with an internship or volunteering is kind of a good way to sort of get your foot in the door and maybe would increase your chances of getting hired at a survey. What do you think about that?
Absolutely. And I think that's true for the state surveys, and it's also true for the USGS. I mean, if we actually hire a regular position, we basically have university right now. It's extra difficult because of COVID-19 and the new requirements within the university to actually get authorization to offer a position. But like I said, we were able to do that for people who had been qualified would have been people with masters or PhDs for research science jobs. But if we do a regular full position, we have to do a regular kind of search and that sort of thing. But if we hire a student, it's much easier. So it's actually really good for the students. It's good for us to fill a short-term niche that we have. It can work out really well. It's just kind of hard to predict exactly what we need. And it matches up with students' interest and their expertise.
But what's the sense? Can you give us a sense of the likelihood of moving from beyond those volunteering positions to some sort of internal hiring process, which might circumvent the difficulties involved in obtaining authorization and going through a more involved hiring process?
Yeah, that's a good question too. I think I kind of conflated two different things. I was complaining about how hard it is to hire here at the university now because the president has to sign off on making a position, basically. That's the one issue. What I should have answered the question more directly. If we can hire a grad student or even an undergrad, but because we're hiring some undergrads too. But if we can hire someone and work and basically kind of have a trial getting acquainted period, kind of see how they do, that's obviously a huge advantage. When we offer a position that's competitive, if we already know somebody is good, we do a fair evaluation of the candidates. But if we know somebody and we know that they're good, their expertise and they're hardworking and everything, I mean, that's a huge advantage. And even if you don't get a job with the survey, like with us, I mean, you're getting a good experience you could potentially translate to some other state survey or even in the private sector. I mean, you get good experience working with us, I think. Does that answer your question? Oh, and one of the things, you can volunteer, but generally we pay people.
Interesting, thanks.
And we have a couple questions in the chat for you. So Harrison Tamoyo says, thank you for the presentation. Did you mention on the employment opportunities slide that there's a role for biology? Could you elaborate on that?
That's actually, yeah, thank you. I threw that in with the USGS because we don't explicitly have any biology. We don't, Yeah, the most we've done is work with U of A people who do, paleontology and geochemistry, but so we don't do biology, but the US Geological Survey actually has such a large group. And under the umbrella of the US Geological Survey, they do a lot of different things, and you can go on their website and see, but there's basically a biological, I don't think they call it biological survey, but there are a lot of biologists who work for the US Geological Survey. So I recommend you go on their USGS website and check that out.
And then another question from the chat from Genevieve Burgeon was, what is your day-to-day like? What percentage of your time is spent in the field versus in the office? Wow, we're getting a lot of questions in the chat room here. That's awesome.
Good. Yeah, that really depends on your position. I think we have some people who are like bedrock geologic mapping is almost entirely what they do, and they spend at least a third of their time in the field mapping. The people who do the surficial mapping, that's less field intensive, and that's what I've done. So maybe at most a quarter of your time. Now that I'm the director, I actually don't get to get out in the field quite as much. But I would say our research scientists who are doing field-related projects are probably spending somewhere between a third of their time in the field, depending on the particular position. So we make our maps on our computers in this GIS environment, which is really cool. It's a great way to make maps. It's much less, it's just a good way, but there's a lot of the map making process is in the office these days.
And then from Eric Laughlin is, as a recent astrobiology and biogeosciences graduate from ASU with only a little field geology experience, are there opportunities for someone like me in the USGS?
Yeah, I think in the USGS that would be the place, and I think they're less. They're less field oriented generally. The USGS is this huge operation. They do a lot of different things, but even amongst the geologists, there aren't that many that are really getting out in the field a lot. So field is less emphasized in that organization than it is in state surveys. And I think with your background, finding somewhere in the USGS would be more likely probably than in a state survey. Just guessing on that, but.
Okay, and then Paris Angel, I hope I said that correctly. I am excited that you are using ArcGIS for your mapping project. What kind of projection systems do you use for geologic mapping?
You're asking me a typical GIS question that would be hard. My understanding would be rudimentary, but basically our maps are in some kind of NAD 83 projection. That's there's lots of different variants on that. And I don't know, if you're interested in that, you can follow up with we obviously have some GIS experts at the survey. So I might divert you to the website and point you towards those folks. Or you can send me an email and I can put you in contact with them.
Okay, and then another question is Joanna Schfeller. Thanks for taking the time to do this. Can you talk a minute about where the strategic mineral projects stand?
Yes, so that's as I mentioned, this is Earth MRI program that the USGS administers. There's not a lot of money in it right now, unfortunately. There's some. But basically, they're working on these cooperative partnerships with states where you say, well, like for example, in Arizona, we knew something about where critical minerals, for example, lithium is the target of the project we have, where our Carson Richardson, who's a recent U of A Ph.D., who's now heading our mineral resources group, we knew that there were these lithium deposits hosted in lithium concentrations in basin deposits. We presented the idea to the US Geological Survey for a cooperative program, and it actually complements our geologic mapping program as well. So he went forward with this proposal. It's in the Big Sandy Valley, so it's between Wickenburg and Kingman, kind of along US 93, if that makes sense to you. So we're going to be investigating those deposits and mapping the geology around them to try to better understand where the lithium came from and how it got concentrated in the sediments. So that's an example. There's critical minerals is a pretty broad field, and there's a lot of interest in things like, well, there's minor critical minerals in coal deposits, for example. And people that have coal deposits are kind of desperate to find other uses for coal because the market for actually burning it in power plants is decreasing. So maybe coal can be processed to extract rare earth elements and things like that. So it's kind of an evolving field, really, the critical minerals, and the US has not paid enough attention to it for decades. Actually, there's a lot of work after the Second World War, and then really not very much for a long time. And then we realized that our supply chains are so vulnerable that I predict that's going to be a really good area to be involved in as a geoscientist in the coming decades in the United States. So that's a roundabout way of saying, yeah, it depends, but that's kind of how these work. USGS identifies an area project that a state survey has proposed, and if they decide to fund it, then state surveys get to work on it.
That sounds like a great opportunity. And another question from Julia is a PhD more likely to get hired than a master's degree at the state survey and or USGS?
Again, it depends on what you do, but I think at the USGS, certainly coming in as a geologist, and yeah, mostly they're PhDs. I think state surveys are less that, I know they're less that way. We are. We advertise a position, for example, the one we just advertised, 2 research scientist positions, and we hired one person with a master's and a fair amount of experience, and the other one is just finishing his PhD. So I think that there's some positions for bachelors, but they would be more like helping out on projects. But in terms of actually kind of having a major role in projects or managing projects, it's going to be masters and PhDs. But I think both of those levels there are opportunities in state surveys for both of those things.
And then another question from Harrison Tamoyo is, does the AZGS incorporate any speleological surveys?
That's a good answer. No, we haven't done that. Yeah, no, we don't. I mean, I think there are some states like maybe Kentucky and West Virginia, for example. I don't think New Mexico, but places that have classic karst and caves, they may do that. I'm actually not sure about that. I kind of think they might, but it would be a small subset of state surveys that would do that.
Okay, and any other questions, you can unmute or post it in the chat. We have just 4 more minutes here, so time for 1 or 2 more questions probably. Okay, well, if you have any other questions for Dr. Pearthree, you can always contact him at his email, or he gave his phone number as well if you want to contact him. And we're so grateful that you came in and gave the talk today, Dr. Pearthree. It was wonderful.
Given everyone's working remotely, Kayla, I should say that phone number is not the best way to get a hold of me. So email is much better.
Yes.
My office. I didn't want to give out my cell phone to all you folks. But yeah, email is good. And then, I recommend get on our website if you're interested in what we do. We have a good website. A lot of state surveys do. You can get a better, more robust feel for what we do and what different states do. And I think if you're interested in hazards at all, definitely check out our natural hazards viewer. I think we're very proud of that. It's nice. Yeah. So thank you all for your attention.
Yeah. It was a wonderful presentation. I know I learned a lot, especially as a geologist looking into surveying. Very neat.
And if you come out with a bachelor's, and obviously I'm gonna say it's true. for a lot of areas in geoscience that, you know, master's degree is kind of the working degree if you want to take on, there are rare exceptions, but generally that's the degree to have to, doesn't mean you can't go to work with a bachelor's and learn some cool stuff, but eventually I think a master's is kind of like the level you should probably strive to be at, to work at, to have interesting work at state surveys.
All right, and with that, we'll close out, and we'll look forward to getting more talks in the spring semester. So as I said earlier, be on the lookout in your emails, and we'll see you next time.